Hi, good afternoon. Welcome to Mobile World Congress. My name is Sergio Palazzari, one of the solutions architects at Nakina Systems. Welcome to the noon presentation on NI Controller and how we can improve mobile service delivery just by looking at network data and analytics. A lot of problems in today's networks are actually caused by network outages. In fact, $15 billion are spent annually on actually dealing with outages and degradations. On average, for every service provider, there's at least 5 major reported outages. That's about one major outage every 1 to 2 months. And those outages typically last at least 2 hours. Those are pretty staggering numbers for mobile service providers. And when you look at the actual causes of the outages, yes, there is some malicious intent, but there actually are a lot of configuration issues in the network. And a lot of the other mobile problems are actually centered around congestion. Surprisingly, a lot of the congestion problems are actually caused by configuration issues. So tackling configuration issues in a mobile network is actually key in being able to improve the overall quality of mobile networks. If we actually look at some of the details, forgot the fishbowl. If your mobile network has poor quality, your goldfish are likely to leap from one fishbowl to another, and you will actually lose customers to competing fishbowls. If you actually look at the detail in a 3G network, a lot of actual problems are caused at the IUB link. The IUB link is actually between a radio node controller and a node B. And you've got a lot of call failures and connection failures that are actually caused by misconfigurations, either of QoS mappings or actual misconfigurations that are occurring at the RNC or the node B or between the two of them. And we found that in a lot of the service providers that we've actually looked at. Things get actually much worse in an LTE environment, and with the advent of small cells, you've got far more network devices, proliferation of a lot of little devices in the network, more handoffs, more trade-offs, and more scenarios where parameters can actually be incorrectly set. And you see that in a lot of cases in not only between small cells and eNode Bs, but also in the backhaul parameters. Nakina's functionality is all created on top of our NI framework. Our multi-vendor solution can actually interact with vendors of different types, different vintages, and perform functions across that entire array of products that we're actually managing. Specifically, our NI controller has the ability to read and audit parameters on all the end devices. So in a multi-vendor network, as we described earlier, Nakina could actually talk through its adapters to either physical or virtual networks, to those actual individual elements, and perform configuration audits. Our actual NI collector does have that capability to not only do network-wide analytics, look at the actual historical values, but as I mentioned, as we move forward with virtual network functions, VNFs, in a network function virtualized environment, we can not only do those types of audits for virtual, but also for physical network elements as well. If you look at some of the detail that we could provide, we could actually start pinpointing with our NI controller where discrepancies are actually occurring in their network. These are hotspots. These are hotspots in your network where there are configuration errors. So here, for example, we've been able to pinpoint some actual issues that may be occurring within a mobile network in the UK. And you can actually see that there are configuration errors and a wide number of configuration errors at these particular cell sites, and you can home in on that. Here's another example where we did provide a dashboard for a mobile provider. They had their view obviously state-based, and we were actually looking at not only a network-wide or a nationwide deployment within the US, but we were actually able to look at which vendor and the types of actual failures that we were actually seeing within the network. Furthermore, we could actually break down some of the audit results and actually look at things like where problems are in the network by service, by region, by vendor. And having that ability to look at topology is very key. A lot of misconfigurations are caused between adjacent network elements, and having that topology knowledge gives us the ability to look at both sides of an interface to determine if there's actually configuration errors between those interfaces. Here we were able to actually look at different types of parameters that are matching, mismatching, and what we call a gold standard. Being able to compare that gold standard to what's in the network is something that's very key. We were also able to do this by different portions of the network technologies, and you could see here that in this example there was a large number of errors actually occurring in the node Bs, and that was some place where configurations were actually highly misconfigured. We also have dashboard type reporting, so at a higher level you simply want to know how good your network coverage actually is. So what types of audits have you run, how much of the network have you actually covered with an audit, as well as how compliant you are to a gold standard. So a lot of service providers are using this type of knowledge to give them analytics as to where problems are existing in their network, whether it's by technology, whether it's by region, whether it's by vendor, where the actual misconfigurations are seen within their network. Here we just have another view a little bit further down. We can actually compare at a regional level where the actual compliance levels are, as well as that you can actually see from a technology perspective where the misconfigurations lie in the network. Nakina's NI controller is actually looking at things at the parameter level. So we're actually reading the actual parameter values in the network and comparing it to what's found in what's called a gold standard. A gold standard is defined for a specific network element type or virtual network element, and the actual parameter value specifically can be enumerated, a range can be defined. There's a number of ways that a gold standard can actually be specified, and Nakina's NI controller will actually be able to determine the discrepancies whenever an audit is run. Here you can see that there were actually specific parameter values that were identified as mismatched within this actual audit. So overall, for a mobile network, being able to deal with, being able to deal and reduce the number of configuration errors is key. If you were able to reduce the actual churn in the network by 50%, you could save $140 million. If you were actually able to have a MTTR of 75%, you could save another $5.4 million. And for tier 1s, it just means a lot of revenue saving just by dealing with your configuration errors much more efficiently. One of the case studies that we did with a service provider in Mexico, Telcel, they're a part of América Móvil. They have a nationwide 3G network, and they have over 40 million subscribers. What we were able to find was a large amount of IUB congestion, and it was leading to a lot of degradations, operations cost, and network churn. Some actual key numbers during some of the audits that we ran. In the radio access network, we actually audited over 26 million parameters. In the backhaul, we audited over 2 million parameters. This is on a daily basis. Being able to do that size of a network, compare parameters at such a detail, we were able to actually determine where a lot of the configuration errors were. We're continually running these errors on a weekly basis. These audits are occurring, like I said, on a weekly basis, and we're analyzing these parameters because humans continue to touch the network. The network isn't static, it changes all the time. So it's key to actually have these audits run continuously and over again to ensure that you have quality network parameters. Thank you.